Trish. All right, get out. What was this before, Mac?
6.63.
Did you put it in your phone?
Yes.
It's now 21.03. Got your stir bar ready? Stir bar's right here. You got the stir thing ready.
No, I don't have the thing.
Get it ready to go.
Okay. Where did? Oh, I put it that back there.
Okay, pH of 1. Yeah. pH of 1. Take your hide off.
Yes.
I added more acid, and the weight is 47.66.
47.66.
Write it down. Wait, Mac. After adding water, I'm at 69.1, 69.20. Got that?
Yes.
Mac, we don't want to do this here. Where do you want to go? Over there. that spoon? Are we going to add the phosphor?
That goes inside of the stir. No.
There we go.
No, it's not. Wait, what? How'd you get a thing?
You brought it over there. Now, I need a spoon.
That's not the right thing. Use this. Okay, fine.
What are you talking about? Right over there. You got a whole little box of them.
Those are different sizes. Fine, fine. It doesn't matter which one you use. You want a spoon. Where? I'll go ask Nana for a spoon.
No.
What?
No.
Then where do I get a spoon?
We need a little plastic spoon.
So can I go get a plastic spoon?
Just
from
don't
there?
try a stainless steel one or something.
Okay. What?
You need to weigh this with just the stir bar. Get the weight.
Oh, jeez. What is it? Okay, now I need to get the little plastic spoon. Do you have a plastic spoon?
A what?
Plastic spoon.
Spoon? How big?
A little one, just as long as it's plastic. Can't.
Let me see if I have one over here. Ah, wouldn't you know that'd be a fork. I have big plastic ones there. Okay. When I put this in, I changed everything, Mac, so I've got to find stuff. Okay. Where did I put you? Going to be in here. I'll get it. Must be in here. I'm just not finding it.
Thank you. Excuse me, Papa.
Clean?
Yes.
Sure.
It was in a plastic bag. What? Is it sticking to the glass?
Shit.
What? Did you get some on yourself?
Get it out of there, man. Put all these chemicals up and I'm done, okay?
Okay. Put all these chemicals up and you're done?
You need to tape up the hydroxide and the acid. Use those blue gloves right over there, the nitrile gloves.
Yes.
You see them? No, over there. See them?
Here, yeah, here.
Put them on and tape everything up. I'm done.
I cannot see. Oh. Must be closer. That is one.
Alright.
Yeah, goodbye. Wait, don't close that. Don't close that.
Don't forget to shut the door down.
Okay. Okay, pH of 5.2. So yeah, so if I boil this off, I should just end up with the yttrium. If not, we'll dissolve it again and try again. I'm not sure if you can see this, but there's some vapor coming off of this. And you don't want to get too close. I mean, you get too close and you can smell it, and then that means you're breathing it in. I'm staying at a safe distance right now. And it turns out you want to turn off the stir because it shares power with the heater. So if the stir's on, it takes power away from heating, so it won't get as hot. This, I believe, gets up to 350 degrees Celsius. So plenty to vaporize water and many other things. Okay, so I'll record it once it's done and try to see if it's yttrium or not. Okay, so it's bubbling out more. Take your stir rod, or in this case your spoon. Try and make sure it doesn't form into a big clump that defeats the purpose. We want a bunch of little clumps. We want little grains. So periodically stir it whenever it's clumping together. Okay, go record later. I don't know yet, but based off of so far, I don't think this is yttrium. It's not silvery, it's white. I think it's yttrium hydroxide, which, if it is, we could just separate out the hydrogen to it and make water, and then just have yttrium oxide, which is what we need if we're really lucky. I mean, so yeah, I think this is yttrium hydroxide, not yttrium. Okay, it's almost done now, so just stir it up. Try to break it up. Okay, it's actually getting kind of hard to do this while holding the camera, so I'm just gonna stop this now. You gotta keep stirring until all the liquid's gone. Okay, and I'll record once it's finally done. Okay, so this is the final product. You see it's gray. Well, yttrium oxide is supposed to be white, and yttrium is supposed to be a silvery color. So I think this is a mix between them. I think some of that is yttrium hydroxide, yttrium oxide, just pure yttrium. I think there's maybe some yttrium chloride, since it was a pH of 5. Like, we didn't get it didn't get neutral to 7, so there's probably some yttrium chloride in there. there might even be some like yttrium nitrate just from reacting with the air, but I doubt it. I mean, yeah, it's probably not gonna do nitrogen fixation, but I'm just saying this stuff is not pure, so we can't use this. So, and I'm thinking if I were to dissolve it in acid, I mean, it may get more pure, but we'll probably get around the same result. So I'm just going to take this and do the original plan of putting it into the vacuum tube we created here, and heat it with the induction coil heater inside the vacuum, and mix it with crushed graphite or activated carbon, and try to make some yttrium carbide, and then take that and do the whole process of electrolysis in the water and cooking it and all of that, and eventually get more pure yttrium oxide. Okay, I'll talk more about that later. I will probably go more in depth, but how I made this, okay, all of the footage, it would take way too long to show you how to make this, so I'm just going to explain this because there was a lot of failure here. But what eventually worked is, okay, gotta get this jar. I believe it was a jar from, okay, video cut out. I just had to get this laboratory book for all of the stuff we did. Okay. Okay, trying to find the page. Okay, here it is. Okay, we got this induction heater here. Okay, we did for this I had to put this tile down just in case to keep the wood table from catching on fire. Had to run wires from here all the way back here, all the way to the fuse box over there, and to the power lines. This needed to be able to do 30 amps that's the requirements for this tube furnace. This not tube furnace, sorry. This isn't a tube furnace for this induction heater. This induction heater costed like $800. Now you could make it for a little bit cheaper, but just for the time and it wouldn't be that much cheaper. I could probably make this for like $600, but this is a pretty good price just for the time. So got this, got it on, it's US solid. Okay, let's see my notes. Yeah, so, and also had to this tube goes all the way back, it loops around, it comes in here, and then this goes out, and the water comes from there. I turn on a valve there, and it comes all the way here, and it cycles, goes through the coil, and then goes out there. Now, yeah, and okay, and I don't remember exactly where I got this jar. Let me see. Yeah, I found it on Amazon. I don't remember the company. I believe it's some shipping company. But anyway, you need a jar wide enough to where you could fit this graphite crucible in. And why you need to do that is, well, you need a vacuum. So you see it's connected to a vacuum pump here. And I tried just an ordinary jar. I bought from Walmart, and it had like a wood lid. Yeah, that thing deformed every time I tried to put holes in it to where it wouldn't make a seal for the vacuum. So you want a metal lid like this, and then you'll tape around the edge for the seal, and you need to cut out holes for the coil to go through, because you don't want the coil to conduct current on the metal. And then I put a ceramic tile in order to seal up the hole. We tried several things. Like, first we tried to get these union brackets, but we couldn't find the ones that were the right size. Like, we searched all over. We searched several stores, and they eventually just put us into a loop of going to a store we had already been to. So we searched all over. The only place we could find it was like at Michigan. It was ridiculous. So, and then tried sealing it with basically our custom-made gaskets I cut from rubber. That didn't work, because even just at this entrance it gets really hot. So it was actually melting the rubber and the electrical tape. So that, and I also was using Loctite and Gorilla Glue. It melted those like white. When I turned this on and tried to run it, it was vaporizing, and there was like white smoke all over. And yeah, that's and then, so what you want is this. Here are and I also tried using Flex Seal. That melted too. So what you want is, okay, here are the things that work. This JB Weld high heat putty, that's that gray stuff there. For any extra leaks, you want to wait, I don't know where I put the can. Huh. Well, I don't swear it was in here. Ah, here it is. Okay. Yeah, this DEI high temp silicone coating, you want to spray that. I sprayed it inside there, inside this side of the lid, to seal up any holes. It can take the heat too. So the high heat putty, this. You can also use this JB Weld high heat gasket maker. And if you need tape, this DEI quick fix tape. Now you can get this stuff on Amazon, or you some of this I got it like AutoZone, but they only had like one can of this. So usually used for, yeah, it says right here, engine blocks, exhaust pipes, gas grills, yeah. So this is stuff you want to use to seal up the holes. And I cut the tile in half so it would clamp on to here, because before I had to make big holes for these nuts if I didn't cut it in half and then clamp it, and that was becoming a huge problem. I couldn't seal it well, so this is so cut the tile in half and then clamp here. Don't try to make a big hole for these to go through, and then seal it all with this stuff. And the putty works really well, but you gotta use a lot of it. I use like 2 things of it. And do not use Loctite. Do not use Gorilla Glue, epoxy. Just a lot of these epoxies they can't take the heat. Don't use Flex Seal. Don't use electrical tape. Just except actually you can use electrical tape here. Don't use it here. Here's fine. It doesn't get so hot here. This just kind of seals the air. But here, do not use electrical tape. It'll just melt. Do not use rubber. Use all of this high heat stuff. Yeah, I'm skipping over like a lot of. I'm just shortening down all this stuff, but it took me a while to figure this out. Also, you gotta use this bowl, because these crucibles, they start heating up and they just break. So can't have the graphite in the coil for how high of temperatures we're going, because it needs to go to 2,200 degrees Celsius to melt the yttrium. And this is the only coil we could get to do it. It came with the induction heater. I tried making other coils, like yeah, like here and here, and several more. These are like, there's several more that like just completely broke. Trying to make it bigger, but with more larger area, but to compensate for the larger area, more turns. Problem is, it drew too much power for this to handle. It could not get to a high enough temperature, so this is the only coil that works. It's about 1.5 inch diameter in that coiled area, and it's 3 turns. Like, I was trying things 6 turns, 8 turns, much bigger area. I was trying to just, so you're gonna have to melt this stuff in stages, because this can't take it. Draws too many turns, draws too much power. Because this does it in pulses. Like, it's not a constant 30 amps, what is it? Yeah, 30 amps, 220 volts. Yeah, it doesn't constantly do it. It does it in pulses. And then if you do too much, it can't pulse right, and then it compensates by like withdrawing the current or lowering the voltage and stuff. It has like transformers in here, and it has a max power output. And so if you want a high enough temperature, you gotta do it in small little batches with this little area. Okay, and then you gotta connect to the vacuum. Here's a gauge here to tell you the pressure. Okay, yeah, that's it. That's how I made it. So I'm gonna take this, and I may explain this more if there's anything I forgot. But yeah, get a metal lid, get this big jar. You gotta use this. You gotta use this small coil with 3 turns, 1.5 inch diameter. Gotta put the yttrium in there and the crushed graphite. 12 times the mass of graphite to yttrium. So, and put it in there, melt it, turning this on. You gotta have the water on. You gotta connect the water. You gotta make sure you connect the water, have it go in, have it go out. Make sure this is tight. Give 30 amps and 220 220 volts to this thing. And yeah, that's it. I'll record another video when I'm trying to melt this. Oh, and you gotta put tape on here to seal the vacuum. You'll see it on the gauge. You need that tape just to seal it. Okay, yeah, that's it. I'll record when I actually am running the machine and doing this. Okay. I forgot this intermediary stuff. Gotta take this and measure it again. Weigh it. Using this wax paper from the kitchen as weighing paper. Basically, it's the same thing, basically. Just not cut right, but yeah, I'll tear it. I tear it. Okay, so originally started out with like 6.63 grams. Yeah, no way. This is just yttrium, because right now I haven't even put all of it in, and it's 9.989 grams. So only way it gain mass is it bonded with something. Yeah, it's like it's 10.55 grams, and that's pretty much all I can get out of the beaker. I'll clean it later. So yeah, that's definitely not pure. 10.55 grams, I'll write that down. Okay, it's gotta weigh this. The carbon, it needs to be 12 times the mass. So this stuff was 10.55, so times 12. 126.6. Yeah, so it needs to be at least that. So tear this little weighing cup. Now this isn't the cleanest most cup. I mean I cleaned it, but I mean it could be better. But considering the conditions in the middle of summer, and it might be over 100 degrees Fahrenheit down here. I'm just doing the best I can. Okay. 2. We need like a 120. Okay, yeah, more, way more, more. This is a lot. That's a lot. That's like 107, 108, 109. $120. Okay, it's like 127.2. Number's fluctuating. Okay. So that's a lot of carbon. More than it can fit in there, so I'm gonna have to half it. Doing separate batches because that is too much to fit in that volume. Okay, so crush it up, grind it up, whatever way you want. Mix it with that and put it in there. I'll do the video after I've done that. Okay, so there it is. That was as close as I could get to the center. It's pretty hard to move it around when it's in there. You gotta put your hands or some tweezers and move everything around. And so here it is. Just gotta tape this up, pull the vacuum, turn everything on, turn the water, turn the electricity, power everything, and then do it. Okay, so just gotta put this here. Wait. Huh. I'm trying different angles now. Okay, you can't see it from there. I guess I'll have to move it around myself periodically. Okay. Gotta tape it. Oh God. Where's the tape? Okay. Worn out from how many times I've been doing this. This tape's almost gone. Go around. Try to make sure it's sealed. It's hard to see. So you gotta feel with your finger looping around. Sealing it all. Let's just see if it pulls a vacuum. Okay, it's got a leak somewhere. I can hear it. More tape. Ugh. More tape. Tape it up. This is a big roll, so it's gotta be. You gotta stretch it a little before you keep going. Okay, you see? This is the pressure it's getting to. It's about as good as it's gonna get. Okay. Yeah, come over here. Yeah. Turn it on.
Got you a helper.
Plug this in. Plug the switch. Okay, switch is hard flip. Okay, turn it on. Yeah, it's ready. Okay, yeah. It's using that vacuum, the oil, a lot of that vacuum fuel, the oil shit, a lot. Okay. So you gotta do this for a while. Oh yeah, it's hot. Till it's done. Okay. I'll record this again when it's done. Okay. Power just went out to this light and to here. Like, it does nothing. So I think we just burned the fuse. So I'm gonna turn the vacuum pump off. It's getting so hot it's melting something. Yeah, there's vapor inside here. I think it was only a partial vacuum since there's vapor inside. Oh well, I'm gonna try to figure out what's wrong with the breaker and try to get power back to this, and then I'll try to figure out how to fix the vacuum pump. Okay, so yeah, look out for this. The vacuum pump could be not working, the water could not be working, or the power could not be working. Looks like power. Okay. Gotta go fix it. Okay. The circuit breaker kicked out. I mean, the fuse kicked out because this vacuum pump takes 15 amps. This takes 30. It was on a 30 amp circuit, so it was trying to pull like 45, and it couldn't handle that. And this vapor that's happening is carbon dioxide, because the carbon's reacting with whatever oxygen's in there. And that's the stuff, that's the vapor coming out. So now I put the vacuum tube on a separate circuit over here. It's on a separate circuit all the way over there, and this gets 30 amps to itself, so we can start. Yeah, so that should fix the problem. Okay, I'll record in a couple hours again. So anyway, okay, that vacuum gauge stopped going down to below 20. But what I think happened is because it's making CO here and whatever else it's making, it's going in here, and this pump, it's having a hard time. It's not pumping fast enough. So oh damn it again. Well, it just went out again. So let's just say it's a partial vacuum. Except I keep having to turn off and shit. But it's a partial vacuum. If I had a better pump and maybe a better seals here, it'd be doing better. But I mean, it's glowing. I don't know if that's gas or if that's the glow. The coil looks different. It's hot. Everything's hot. It will burn you if you touch it. Like I've already tested that. Yeah, it's hot. Tried using the laser thermometer I have. Can't really see stuff through the glass, so I'm just reading the outside temperature of the glass pretty much. So yeah, and I'm gonna have to go figure out what's wrong with the breaker. Okay, goodbye. Yeah, here it is. Yeah. Okay. See, that's the 30 right there. Oh, and I'm not sure if I said this, but when wiring up those outlet areas, back over there, let me just walk over there. Wiring out those outlets, you gotta use 10 gauge, at least 10 gauge wire. And it's a pain to cut and stuff, but you gotta do that because anything smaller can't pull, isn't able to pull the amperage. Okay. I don't know why I went out, put this on a separate thing. Maybe one of these lights is connected to the same circuit. Or the fan. I don't know. Anyway, if you're building this, try to get a better pump, better seal, a stronger pump. Not so messy of a system. Try to get better wiring, better power, so it doesn't keep shutting down. Okay, yeah. Record again later. Okay. Yeah. So, that thing's going out like every 5-10 minutes. So, I just leave the vacuum on, so try to pump it out as much of the carbon dioxide as I can. It actually starts going down, so I think the pressure goes down, so I think I was right about it being carbon dioxide, because when the thing's off, it stops producing carbon dioxide, and whatever other gases, so it has time to kind of catch up. So yeah, so leave the vacuum on, check the breaker, but if ideally you'd make a better system than I have. Yeah, this might work, this might not work. Just gotta wait and see. Gotta do this for like 3 hours. Yeah. Okay. Goodbye. Okay. So, I think I figured it out. Over there. Oh, it just shut off. Okay. Well, over there, there's a camera. Okay? And that's connected on the same circuit. So it must be taking like, I don't know, 5 amps or something, 10 amps. And I'm pretty sure it's on the same circuit. So I'm going to disconnect that after I reset this. And maybe that'll stop the blackouts. Blackouts are a little less frequent. Now they're more like every 10 to 20 minutes. But still. Okay, just gotta unplug this camera. And you know what? Unplug whatever this is. It's all in the same circuit. That should be done. I think it'll work now. But I thought it would work before. Maybe I'm forgetting something again. Okay. That's backwards, but the 735 output current amps. But again, since it's doing 30 amps, I said it was doing it in small bursts, so it's only sending like 730 something, which is more than before. Before it was like 693 or something. Yeah, so it only does that amount of amps in small bursts. That's the beeping. It goes beep, beep, beep. Yeah, it's just sending out that current in small bursts. So I disconnected this stuff, and hopefully no more blackouts. I think it will. Okay. Yeah. There. Okay. So, it did not. It keeps stopping. I'm plugging in that the security camera and other stuff hasn't stopped it from shutting down. Yeah, it's a little less frequent, but it's still shutting down. And earlier, this fan shut down, which doesn't make sense. It's on a separate circuit. It's on a 20 amp circuit, so I don't know, maybe I need to turn off all of the lights and stuff. Maybe we're just drawing too much power overall, but that doesn't make sense. I'm not exactly sure. I don't remember exactly how we wired it up, and I'm pretty sure to the landline it's something like 150 amps or something. I'm not sure, but something like we should not be taking so much. That two separate parallel circuits are shutting down, not running too much. Okay, well, that's it. I don't know what's wrong. Okay, so here's it. This has been 3 hours, but later it started turning off around every minute. So I think I've gone to that switch, turned it back on and stuff for over 100 times. So, and look, this vacuum, it's spilling its oil all over the place. It's being pushed way too much. So we're gonna stop it once it finally shuts down for the last time, and then I'm just gonna let it cool off, and then I'll take it out. Okay, that's it. And I need to clean up. So yeah, this is what it looks like after. Turns out the wood support was burning inside of it. That's what's left of it. Even though I had this insulation under it, you see that's right where it was sitting. Okay, and here it is. This thing kind of melted and I guess reformed in this shape. So gotta crush it up. Yeah, let me get the crucible. Mortar and crucible, yeah, here. So I'll crush it up with this and then put in deionized water. So yeah, I'll stop and video when I do that. Just gotta get some stuff out of the way and cleaned. can't hold this. Okay, I guess just I'll show you periodically what it looks like. I could do it in smaller batches so it's easier to manage. Get one. Jeez. Is there another one of these I could get? Just make it easier too. Guess I could put in the measuring cup.
Pulverized.
My arms will get sore in about 30 minutes.
Let's see what it, how, is it tearing up at all?
Yeah, it's getting smaller.
Let me see.
Yeah,
Oh.
I split it in half, so I'm gonna move because it can't all fit in here. So I'm gonna move this into there once this is well pulverized. Before it looked like this.
Oh, that's not small enough?
No, that's not small enough. It needs to. You see at the edge right there
Yeah.
how small that is?
Uh-huh.
That's how small all of it needs to be.
Do it a little bit at a time, and you'd be sure you're doing too much at one time, maybe.
Okay, so transfer a little bit more back.
I'm just saying, you may
Yeah.
be able to see, and it does it better. Is that your phone?
Yes,
Oh,
it's video recording this.
oh, okay. Here's a little container. Oops. It's kind of dirty, so you can't use it, can you? You want to go get your clean container out of the house
Yes, please.
so you can. These are throwing up.
So just grind it up till you think it's a fine powder. Just until you basically can't tell the difference in sizes between all of the powder. They're all just so small you can't really tell the difference. Plus, if you feel like it's a lot smoother to grind. Now, maybe a lab setting they have a better way of grinding this to be much finer, but yeah. I think that's about as fine as it's gotta get. Try to yeah. Okay. Yeah, it says on the back of this is from Cole & Mason. That's where I got this mortar and crucible, I guess. Yeah. Yes, I think so.
Did it crush better with not so much in there?
Yes.
Thought it might. What is this? I wonder. He's not sure where the water went out here. needed here with so much.
Yes.
Thought it might be.
Okay, there. So there it is. Maybe a little less than that. Oh, jeez. Yep. Now. Okay. Oh. Oh, there's water literally. Oh my god, what's blocking it? Oh. Yeah. Okay. Okay. Transfer. Whew. Okay. Fogged up. Hard to see. Put the goggles on. Okay. Keep going. I can't see with these goggles. Almost there. Okay. That's fine enough. Yeah. Okay. I'll just transfer all of that to some deionized water. Okay. Okay, so just transfer that into deionized water, 20 times the mass. So for this, it's about 2 liters, like 200, a little more than 200 grams of, I mean, no, not 200, 2,000 grams of water. Yeah. Okay, so you put it in 2 liters of water, make sure it's agitated, stir it up, and then have it sit in here for 24 hours. Just come back the next day, and then you're gonna boil off the water. You'll probably filter it, boil off the water, and then after that put the powder that's left in to the oven and heat it up, and then you should be left with yttrium oxide. Okay, that's it. Okay, so I figured out where I got this jar. Wait, let me just get my gloves on. Okay, I figured out where I got this jar. Got it from Anchor and Hawking on Amazon. It's like 96 fluid ounces, and it has a lid. It has a top wide enough to fit the little crucible bowl. Pedestal. Mortar. I guess it's mortar. Graphite mortar bowl in there, and yeah, so, and it was like $50, $53, something like that. So you could buy this on Amazon, or maybe use a different jar. But that's what I used. Okay, here, after you take the thing and put it through deionized or distilled water like several times, like 3 times, and you made sure to agitate it, so you filter it out and keep replacing and giving it new water and filtering it. Okay, you gotta then boil off the water. So here I got this funnel thing, milk carton cut top funnel. So slowly. Oh yeah, keep going. Okay, it did not get that. So I'm gonna have to do that again. Just oh wait, nope, don't want to pour that back. Looks like it's spilling some. Okay, let's do this again. Yeah, it's not coming out. Okay, you gotta scrape it out, I guess. There's gotta be a better way to scrape this. Ah, okay, I gotta find a better way to scrape this. Okay, I gotta use this wood little thing. Yeah, every time we transfer to another container, now this is not ideal, as you can clearly see, because I'm scraping it out and I spilled some and stuff, but every time you're transferring to a container or doing some process, you gotta lose a little bit. You want to keep from wasting it. Try to not lose it. Ugh. So you want to wash this down a little more. With the distilled water. Okay, that's about as good as I could get it. And it's pretty full, so can't get it. Don't want to get any fuller. And dry off all of them. You know what? I'm gonna move the beaker. See, this is just dumb. You don't want to soak all the electronics. Try to ruin everything. Jeez. This way. Oh. Okay, move this somewhere else. I'll get the funnel off later. Okay. This should be good. Okay, now put everything back. See, this is clearly not ideal. Totally break that glass. Gotta be careful. Okay, plug this in. Okay. And of course you can also use this thing for stirring. Ugh. In fact, I'm gonna do that. take one of these. Okay, you can't really tell that well, but I hear it stirring. So do that for a little while, then heat it up and boil off the water. Okay, I'll stop the video now and then show you later when I get it boiling. Okay. Okay, so here's the idea. Well, it's boiling a little bit right now, but the idea is I can separate some of it out, put it in here, and use this coil thing to heat it up to make this go faster, because it's already been almost an hour. Okay. Put this back here. Okay, I'm just gonna leave that there. Okay, pick this back up later. Okay, here it's boiling. Now this coil could be a source of contamination, but I don't think so. I don't think it's getting that hot to release any like metal ions or anything, and it was clean. It was like brand new, so it's much faster than the hot plate. But yeah, they're boiling. Oh, I think it's been like an hour and 30 minutes since I started trying this, since I first put this thing on the hot plate. And okay, okay, I'll do this again later. Okay, it's boiling more now, but this is taking forever. So I mean, it's been like 3 hours. Right now it's like past 10 o'clock at night, so gotta shut this down and continue in the morning. Okay. Because this is a fire hazard if I'm not awake. Okay, I now got this thing, and since it's not inside of the container, it's much less contamination, plus it's a much faster resistive coil. It's much bigger, much more power, so that's good. Yeah. I'm also still having the rest of it be done over here. Yeah, but this one with the bitty stove and Corningware is much faster. Okay, this is the end result. That took about an hour and a half. So just gotta scrape that off, put it over there, and if I have to, I'll use some more distilled water and like filter it out with this funnel and siphon, or yeah. Okay. Yeah. Okay, so here it is, collected. Now, I measured the mass over here. It was like 65 grams, so it used to be 72 grams. Of course, you tear for the container, but zeroed out, you know. But that's like 7-gram loss. That's like that's like 10% of the material. So throughout this whole process, I've lost around 10%. Okay, so next step is just to put it in the tube furnace and heat up all the carbon off to become CO2. So yeah, carbon dioxide. So yeah, that's the next step. But I don't have a trying to find a way to connect the tube furnace to this oxygen tank, and the regulating gauges and valves that I have, like, they don't fit well. So I just gotta find a good, and so I just gotta find a system to hook that all up and put this in and stuff. So I'll continue the videoing once I find that. Okay.
Take this over, put it on the grinder, not the grinder, but the wire wheel, and polish it up back there about 1/4 of an inch. Alright. Leave it alone.
You don't think they're going to separate?
I don't know. Then my hand is shaking like a damn leaf. Heat this big one first. Alright. Just shove it up there.
You hold this for a little bit.
Okay, heat that first. Get it red. Up there next to the light blue is the hottest part. That's where you want to. Okay. Put it right on the rod. A little bit more. Good, no. No, go ahead and feed some oxygen now.
Let's go.
Shut the oxygen off.
The oxygen's off.
A little bit of oxygen. A little bit. A little bit more. Okay, let's try it. Get this all over here. Nope, you haven't got it red yet. That's all right. Just hold it down where the light blue is, right next to the blue, right there. Let me know when it turns cherry red. Can you tell the color or something?
No.
Okay, no wonder you have trouble with it. Okay, that's good. Bring it over here, up here at the top. Keep that solid. While you don't heat that back there. You don't need that heater. This up here is where you got to build it up. Easy now, you're going to melt it too. We almost got it. Ah.
Turn the oxygen off.
Yeah. Okay.
What are you putting on there?
It's flux. It's just to get it to not react with oxygen to make it stick to the metal.
Bring it a little closer. Turn it up a little bit more. There you go. Bring it down close. Put it right on that.
Jim,
What?
Papa wants to go to Ross's and Marshall's. Is it okay if we go? Or did you want to go?
Here, put it back here.
I think you could go. I don't think Papa would mind.
Where you gonna go?
Ross's and Marshall's?
Yeah, go ahead.
Okay. Have you got your phone?
Yeah.
Huh?
No, but I'll come and get it. Yeah, see if you can smooth it out a little bit. Okay. Yeah, bring it over a little bit. Get down there, get the threads hot. Okay, bring it up this way a little bit. Okay, move it. Keep moving it. Yeah. Just fire down close to on them threads. On the threads. Keep swinging it over toward the brass a little bit. Alright. Put it on the rug. Okay, get away from it. Turn it over, see if we miss any bad spots. Probably. Yeah.
Okay, anywhere else?
I don't know. Looks like it's filled in. Is that where it needs it?
I'm not sure if it needs it, but
Oh, look at it close. Put your nose down.
I think there's a few holes.
Okay. Let's add some more.
Yeah, that's good.
Oh, you're learning. Hold it right there on the threads. Wave it back and forth over here. Put it right on the rod. That should do it.
Okay, well, this is what it looks like after all that. We're making this to go and connect to the tube furnace so we can feed it oxygen. This is just like makeshift connector. And of course, I bet you saw we had the fire too hot and applied too much heat, and we made that hole and we had to cover it up. And it's all crooked now, but I think it'll work. Probably wrap some tape around it just in case there's any minor leaks, just seal them. Okay. Got this all set up here. Okay, so here's the oxygen tank. Turn this valve and then regulate it with this valve. It's gotta go to this tube furnace once I get the stuff in there. it's not working. Okay, you just gotta tilt it a little bit. Okay. Okay, it looks like the thing's full now, so this is a limiting factor. This is, if you want to do larger doses, you got to make a bigger tube furnace or buy a bigger tube furnace. These things to just like kind of hold it in place. Okay. Okay, now and connect the other end to the other wire. Okay. Okay, that bucket's full of water. That's just to test the rate of the oxygen. Okay, so I'm turning the valve over here for the oxygen. Huh. Turning the gauge. So you want it to be about a bubble a second. I don't know if you can see that, but that's about a bubble a second right here. Now, let's place it on here. Okay, I don't feel oxygen coming on this side, so that's a sign that it's not working. I'm just gonna... Oh. Crap. God. That's not good. Okay, I'm gonna turn this off for a bit while I fix this. Okay, so it was like way too packed to where the oxygen couldn't get out. So I had to like take out half of it. And you saw some of it spilled, so that's a loss. Just trying. Okay. Back to the bucket method again. Okay, that's about good. Just make sure. Okay, I can feel the oxygen coming out on this side now. So that tells you it's working. Get this bucket of water out of here. This guy should be ready to go. Turning the voltage and the current up. Okay, it's 30 volts and 10 amps. I'll turn it up later if it needs more. Okay, so you gotta do that. I'll check the temperature later, but you gotta get this to like 800 degrees Celsius for a couple hours. I'll do a video when I get the paper out and get the better numbers. Okay. Stopping the video for now. Yeah. Okay. Okay, so it only been like 20 minutes and this caught on fire. Right over here, here's the box. The box still works, but this wire here caught on fire, and then it started catching the tape on fire and made a whole hole like right over here. Well, that's what I think happened. I didn't notice until I saw it on the camera up there back inside. Rush out here. So yeah, it was working until it caught on fire. So I'm gonna have to get back on this, but get better wires and I don't know, maybe put some fire resistant tape, paint on this stuff, keep this from happening again. And one of the fire extinguishers didn't work. This one worked, and that's what that white stuff is. It's the stuff from the fire extinguisher. But this shit did not work at all. Like, I pulled the pin, it's not going. So yeah, I've unplugged everything and I'll have to fix the equipment before I can continue with the experiment. Okay. Okay, so here's a video of the actual fire caught on the security camera, and when I put it out, because I wasn't filming with my phone when the actual fire, because I wasn't there, and then I had to put it out. So, but I got the footage off the security camera, so here it is.
path to where the gas, to where the oxygen couldn't get out. So I had to like take out half of it. And yeah, that's about it. I get the bucket of water out of here. You gotta get this to like 8. think it's somewhere. Hot gloves.
What cut on flash is that?
That's why we can't just leave it because it was a fire hazard. It really happened. Jesus Christ. I should have been checking it more. We're moving this out of here. Seems fine. I'm top of it.
Yeah. That'd give you some space to put it. Burn that. Did you have to go?
That's why you.
Okay, so had to make a new tube furnace. This time, replace the wires, replace everything, but this time in the center there, I put some thermal paste. Now it's not electrically conductive, so it won't short the wires, but it's just thermally conductive, so it spreads the heat around this, so the glass won't crack from the heat. That's what happened to the other one. It have a bunch of pieces of it. So just made a whole new tube furnace and with a longer tube. And here's the yttrium carbide from last time. Gonna put it in and try this again. Okay, so, before I do this, a nice tool for this. Oh, this tube is wider than the other one, so makes it easier to get stuff through. And you notice I didn't bend it this time. So we'll just have to deal with the exhaust at a longer way. Gonna be a pain to get out later, but that's what that little hole's there for, is to hook on to. Just a little further. Got it. Further. Okay. Have the wires here. Got rid of the alligator clamps. Don't think they were able to handle the current and the voltage, so now they're just hooked onto the wire with the 10 gauge wire here to the nichrome wire that I had to make new, and I had to loop around. Yeah, I had to redo the whole tube furnace again from the previous video. But again, this time put thermal paste and non-electrically conductive, but it's thermal paste to conduct the heat and spread it around more evenly. Okay, now just add some oxygen. Turn this on. There's no heat coming off. I'm so confused. Let me just pause this. I'll come back when I figure this out. Okay, so got a multimeter out, tested the connections, the wires are good, the heating coils are good. It's just there was a bad connection. I don't know what, there didn't seem to be contact between the wires. I just fixed it and it was working, so I'm gonna do it again. It was weird. Oh, and if you want to check the temperature, I think I've said this before, but you could use an infrared thermometer. I have one over there. I'll get it later. Let's turn this down. It's already like burning something, so. Okay, that's good. And slowly increase it over time. And make sure I have a fire extinguisher. It's over there. I think you can see the wire glowing. Yeah, you can see it. Oh, is this out of focus? Yeah. Okay, now you can see it better. That might be, that smoke might be the insulation, or it could be the thermal paste. It looks like the thermal paste isn't able to handle this. Maybe it'll help the tube a little bit. Yeah, I'm staying here. Gotta wait to see if this thing catches on fire, and I gotta put it out. Gotta go put on some ventilation. Yeah. Ventilation, fancy speak for turning on the fucking fan. What the? And now the fan's off. They're sparking, so I think it's reacting. Gotta run this for a couple hours. Why is it turning off? Did I lose connection? Okay, gotta fix this. I'm gonna pause it. Well, this wire here lost connection. Like, if I put it here, wait, let me just hold this here. Put this here. Put this here. Yeah, you see, no connection. If I do it here, there's a connection. So somewhere along here, it lost connection, and I And I scratched the wires to make sure like the ends are conductive. As you can see, there's connection like between just a little bit here and a little bit here. So, but these aren't connected. And also, you can see it's still cracked here. So the heat was still too much for it. It still cracked the tube. But it was making this into the brown powder. So I don't know. Maybe I'll make another tube furnace, try to improve the design, or maybe I'll just put it in an oven and try to oxygenate it that way. But it seems like this was working. I'll have to test this to see if I was making yttrium oxide and if this worked. But this new design for the tube furnace I thought would work didn't. So, going to have to figure that out. Well, that powder may be yttrium oxide. It seems to be what is described in the paper. So, but I won't know for sure until I actually try to use it to make YBCO. So, just gonna call this the attempt to make yttrium oxide, because I'm not sure if I actually did it, but I think I might have, because I followed the procedure in the paper that I'm gonna put in the description, of course. So yeah. Now, of course, I've said throughout this video that there were a lot of things that went wrong and can be improved upon. The vacuum chamber, vacuum induction chamber, the tube furnace. I'm gonna have to make another one of those. I think I have a new design of going to use some ceramic and then connect it to the glass and some exhaust wrap in between there. And on the ceramic, that's where I wrap the wires, so the wire isn't directly touching the glass. And I gotta go slower, and I'm gonna get a thermocouple so I know what temperature, because I might be going too hot or changing temperature too quickly, which is maybe why the glass is breaking. But we'll see. I'm gonna make this new design because I need the tube furnace to make the YBCO. So yeah, actually doing all of this, I found that there is actually some tube furnaces that you could get that could do this temperature range for like $250. And after all this time and money I put into it, I mean, it may have been cheaper just to buy it, but I mean, maybe if you do it right the first time, it may actually be cheaper. But so here's to hoping you learn from my fuck ups, honestly. Oh, jeez. And I've been crazy in this video. Like, personalities all over the place. It's kind of weird. Like, I'm posting this to people, but it's like I'm just talking to myself. I'm just recording it. Made me edit this out, but I don't care. So yeah, just skip over this if you want. So yeah, I think I might have done it. I'll just put this as like attempt 1 at making yttrium oxide, and then in the next video, when I get this stuff and find the time to work on it some more, I'll make another video on if it actually worked and making YBCO. Okay.